Hello, welcome to lesson number 4 in the Forces in Motion unit. Today we're going to be looking at graphing motion. So we're going to take the motion map that we did last time and we're going to convert it into a graph. So there's two things you should be able to do. I can draw a graph showing the change in position of a moving object. Remember position, where something is located. I can describe the motion shown on a graph of position. So you should be able to make a graph using a description or a motion map, and you should be able to then describe that motion as well in graph form. So let's go on and see what we see. All right, so here's our first example. What we're doing is we're taking a motion map up here. Okay, motion map, which we got used to doing the last time. What we are then going to do is we are going to describe that motion map, okay? And then we're going to put it on a graph. This over here at the bottom is going to be our graph. Now, what is this graph going to show us? Well, like we should do pretty much almost every time we make an x-axis, we're going to put time here, right? So this is 0. Okay, and then over here on the y-axis, we are going to put position, where the object is at right now, okay? You can think of it also as distance if you want, but the position and the time, okay? So what we're going to be doing is we're going to be converting this into information that's going to help us put it on this guy, all right? So I am going to be describing these motions, and each color represents each thing, and you can see I labeled 1, 2, 3. What you should do is split your motion map into parts equal to the number of things that are happening. So here we've got one type of motion happening, and then a second type, and then a third type, okay? I actually made an error on that. I should correct it really quick. Just need to add a dot right here so that we know that time actually went by. Okay, cool. So now we're back, and we're ready to get started here. So if we look at part 1 here, this object starts at the point of reference, right? So starts at the reference point, okay? And then it's going to be going in the positive direction with a constant velocity. Okay? So what does that look like on our motion graph? Well, on our motion graph, 0 is going to be the reference point. So we want our object to start here at 0, okay? And the motion is going to be happening in the positive direction away from the point of reference. So it has to be going up because this side is positive and this side is negative, okay? Just like it is in math class. So the object has to be going up, and it's doing that with a constant velocity. What constant means is that it doesn't change, right? So the rate that it's traveling at, how it's going to change its position, is not changing, right? And if you think about velocity, it's really just a change in an object's position, right? So how is the position changing? The same way every time. So what we want to do is we want to get a straight line tool. We want to draw a nice straight line. And then, so this would be really fast velocity, and this would be a very slow velocity. This is more like a medium velocity, so we'll just do something like that, okay? So that's going to take care of number 1. That was me making a check mark for us. And now let's go back and write the description for part 2. Oh, I didn't tell you for how long. Ooh, yeah, some of you may have noticed that. I need to tell you how long. So 0, 1, 2, 3 seconds. So this would have been 3 seconds. So on our time graph, we should probably put a 3 there, okay? So if you do have a graph that has marks for time, you could do that. This is more of a conceptual thing. I don't really expect you to necessarily graph all the points exactly right. I just want you to get the concept right, okay? So that's the least important part of this, is graphing the time. I mean the seconds, the number of seconds. Like obviously you know that time goes by. You can't time travel, so a straight up and down line would not be possible, right? That would mean you're changing position infinitely in time of 0. That makes no sense. Okay, so let's do number 2. In part 2, we are going to stop for 0, 1, 2, 3. 3 seconds. And what does stop look like on our graph? Stop looks like the change in position. How the position is changing is that it's not. So you're staying in the exact same place. So if, let's say we're staying right here. Okay, that should be straight, sorry. You're going to grab your tool and you're going to make your line like this for 3 seconds. There we go. So then that would make, you want to put another 3 here, right? So that would be 6 total seconds. So 0 seconds and position of 0. We've now increased our position. So let's say that we are at a position of 5 meters or something. Okay, so we went 5 meters away, right? I made this number up. You will not need to do that necessarily, but you can think about it that way. All right, so we did that for 3 seconds. Now we're done with part 2. We need to look at part 3 now. So in part 3, we're still going to be moving away, okay? And we know for how long, 1, 2, 3 more seconds. And are we going faster or slower than before? Well, these lines are smaller, right? So we'll be going slower, okay? So we're going to still be moving away or positive with a constant, and in this case, slower velocity. So V for velocity for 3 seconds, S for seconds, okay? So we know we're going to go all the way to 9 seconds here. That's literally not a 9. Sorry. That is a 9. Okay, so let's get a green tool here, and we will sketch this line real quick, okay? So this is a slower, it's a slower velocity, so the line's going to be not as steep. So we can see the steepness of this line here, and we're still going away from the reference point, right? So we're going to start here, and we're going to move slower. How about like that? That's much slower, right? Sorry, I missed a little bit. I'm going to try and fix it for you. Oh, this is how you fix it. Hold on 1 second. Nope, we're just going to have to deal with it. Imagine those lines are touching though, huh? Okay, so that's our first graph. So if we describe this graph, you can see on this graph we're going in the positive direction with a constant velocity for 3 seconds. Then we stop and wait for 3 seconds, right? And then we're still moving in the positive away from the reference point, but with a slower constant velocity for 3 seconds. Okay, so that's how you would do one of these basic problems. And the key to doing this is being able to write this description. If you can write this description, you'll be able to go back and forth between these two things really easily. I have a couple more I want to show you that are just like basic examples, so they'll go a little faster. Okay, so let's look at this one here. We started somewhere far away, right? So remember, we're supposed to describe in the open space down here, right? So let me just describe the motion for you. So this is where we would be describing. So this object starts somewhere away from the reference point, and it's in the positive direction. Okay, so if this is 0 and 0 is our reference point, so 0, which is the reference point, this is the time graph, this is the position graph. You have my apologies, O's are hard. Okay, we know that this is the positive direction, we know that this is the negative direction. So we start somewhere away from the reference point. So let's say we're going to start right here on our graph. Okay, that's going to be this place right here. Okay, now we are going to be traveling in the negative direction. I just put parentheses around that so you can see, with a constant velocity. We are going to pass the reference point, and we're doing it for 1, 2, 3, 4, 5, 6. For 6 seconds. Okay, so let me get my blue, and we'll draw the graph, okay? If you think you know what this graph looks like, now would be a good time to pause the video and try and draw the graph yourself. Okay, so here we go. We started somewhere far away from the reference point, but it's in the positive direction, right? Because this arrow tells us that. So we're starting up here. Constant velocity, we are going to actually go past the reference point, which is 0 on our y-axis, okay? We're doing that with a constant velocity, so as long as the line is straight, we're chilling. I can make it really fast, I can make it really slow. Since we're not comparing it to anything else, it doesn't really matter. So your graph might look like this, it might look like this, and it'll be okay. So something like that would be just fine, because we know that the object passed the reference point, right? So it went to the left of it here, which is in the negative. Down here, this is below 0, so we'd be getting more and more negative as we go down towards the negative sign, right? So this is like really small negative numbers, and this is like negative infinity, okay? So keep that in mind. I just wanted to show you kind of what it looks like when you cross over the axis. It means you're changing the position to a different value, either positive or negative. You're changing the sign, okay? So for you math people, that's probably your jam. All right, so here we're on to our next problem. This one has got non-constant motion. So this is probably the hardest version of this. But again, if you can see this and you can describe it, then you're going to be just fine. Okay, so let's describe the motion here. We're going to start behind the reference point. Okay, so that means that we're starting in the negative values. So if this is 0 and this is your position, and this is your time. Sorry, I should have wrote this in before I forgot. We're going to start, let's say, like here. Okay, that's where we're going to start. And remember, this is our reference point. Okay, we started there. Then we are going to do what action? Hopefully you're saying, well, you speed up. Okay, we're also traveling in which direction? The positive over the negative. So move, positive. Apologies, I need to delete those. I have a student who said they're having a hard time reading this. I'm going to make it better. Speeding up for how long? 0, 1, 2, 3, 4 seconds. Okay, so now let's grab our blue line and let's make this thing happen. Okay, started below the reference point, somewhere in the negative direction. We're going to start off with a low speed. The slowest, that's a really slow speed. The slowest speed you can go is no speed at all, right? If your position isn't changing, then you'd be drawing a flat line. That would be a speed of 0. But we know that we're starting off kind of slow, so we want to go a little bit steeper than 0 to start. And then we're going to get faster as we go. And we're going to cross the reference point and keep getting faster, right? So we're going to speed up, so the slope of the line is going to tilt steeper to make sure it's getting faster. So this very long line here is representing a very fast speed. The steeper the line, the faster it's going. Okay, because the slope of this line is showing the velocity, because velocity is change in position. Okay, all right, so that's the first movement. That's number 1. And so that means that this marker should be at 4 seconds. Okay, so then let's go back and describe motion number 2, which hopefully is easy. Motion number 2 is that we stopped for 1, 2, 3, 4, 5, 6 seconds. And remember, we just talked about what that looks like on the graph. We talked about how when you're not moving, that means your velocity is 0. That means your position is changing by 0. So that's literally a flat line. I'm going to make it pretty long because it's supposed to represent 6 seconds of time passing. So this marker should put you at 10 seconds because 4 plus 6 is 10, right? So that means that this segment is 6 seconds long. And then finally, we do the third motion. And this one is hard, right? Because we are going back towards the reference point. So we'll say towards the reference point, which we know in this case is the negative direction, okay? Right? So here we went towards it and then we went away from it. That's the hard part. So we can classify right as positive and left as negative. So if we said toward, that's why I'm including these values here, because you could also just say left, right? Same difference. Negative. Then here we go to the left. We are going to be, what are we doing? Slowing down. And we're doing it for 1, 2, 3, 4. And we're going to end at the reference point, which is important to do. So let's draw what that looks like. Get our curve drawing tool out here. We're going to start really fast, right? So start super steep. And then we're going to slow down to a stop right there. And that should have taken 4 seconds, so that should be at time 14. Okay? So I just want you to understand what that looks like. I'm hoping that this is kind of going to make sense for you. Please come back to this video as often as you need to. This is going to be hard. But I've given you, hopefully, enough ways to see this that you should be able to go back and forth. Once you get pretty good at this, some of the practice will actually be going the other way. So taking a position time graph like this down here, describing it, and then drawing the motion map. Okay, so there's going to be a lot of must-do for this assignment. And actually, it's all going to be must-do. So you're going to want to do all of it to make sure that you really know what you're doing. Okay? Thanks for watching.